Assalamualaikum warahmatullahi wabarakatuh. We are from Group 11. We'll be presenting our Geology Technical Report. And in this video, we will talk about local rocks, minerals, and fossils that we found in Jabatan Mineral dan Geoscience, Kuching.
GMG Malaysia Sarawak branch plays a key role in managing and exploring the slate's geological resources. During the tour, we had the chance to study geological materials and process crucial for engineering geology. We examined slate and other rocks from nearby quarries and natural sites to understand their characteristic, formation process, and potential use in construction projects.
Hello everyone, my name is Gotli Anausin. So today I will briefly introduce you to the two types of sedimentary rock, which are shale and sandstone. So what is shale? Shale is a sedimentary rock that forms from compacted clay and silt. It is known for its smooth, fine-grained texture and its ability to split into thin layers. So shale typically appears in shades of gray, but it can also be black, red, green, or brown. It is relatively soft and brittle with hardness of 2 to 3 on the Mohs scale. You can often find shale in extensive layers within sedimentary basins. Shale is used in making cement and bricks and is crucial in extracting resources like shale gas and oil. So let's move on to the sandstone. So what is sandstone? Sandstone is another sedimentary rock formed from compacted sand particles, and it has a gritty texture and can be quite durable. Sandstones come in various colors including tan, brown, yellow, red, gray, or white depending on its mineral content. With a hardness of 6 to 7 or more scale, sandstone is stronger than shale and often forms in beach, riverbeds, and desert. Due to its strength and beauty, sandstone is widely used in construction as a reservoir for oil and gas. So in summary, while shale and sandstone are both sedimentary rock, they differ in formation, appearance, and uses. Shale is fine-grained and brittle, while sandstone is gritty and strong. Each play a significant role in both nature and industry. So that is all from me. Thank you.
Hi, my name is Fabian Liban, matrix number 101328, and I will be explaining on igneous rocks, which is volcanic breccia and Kuroko O. So, first of all, volcanic breccia is an igneous rock characterized by its smoky gray, black, red, brown, or green color. It consists of angular rock fragments larger than 2 mm within a finer grained matrix formed through explosive volcanic activity such as volcanic eruptions, pyroclastic flows, and lava flow brecciation. Its coarse grain texture includes volcanic glass, feldspar, quartz, pyroxene, and olivine, and it can appear dull to vitreous depending on the amount of volcanic glass. Volcanic breccia is commonly found in laha deposits, pyroclastic flow deposits, and near volcanic vents. It is similar to sedimentary breccia and agglomerate but differs in formation processes. Commercially, it is used as a decorative stone in construction and landscaping, as well as aggregate in road construction and foundation bases. Let's move on to Kuroko O, which is an igneous rock typically associated with large sulfide concentrations linked to volcanic rocks. It contains valuable metals like silver and gold, alongside base metals such as lead, zinc, and copper, giving it a dense and thick nature. Its appearance is often dark or almost black due to the presence of sulfide minerals, and it may exhibit fine-grained, banded, or brecciated textures. These deposits form in underwater volcanic environments with active seafloor spreading or volcanic arc systems, where metal-rich hydrothermal fluids deposit sulfide minerals on the seafloor. Kuroko ore is similar to other volcanogenic massive sulfide or VMS deposits found in regions like the Iberian Pyrite Belt and Cyprus. The extracted metals from Kuroko ore are essential for manufacturing batteries, galvanizing, and electrical wiring. So that is all from me. Thank you.
I will talk about two different types of metamorphic rocks. The first one is quartzite. Quartzite is a tough metamorphic rock known for its light color and grainy texture, formed from quartz grain that undergo intense heat and pressure. It's extremely hard and durable, making it resistant to wear and tear. You can find quartzite in mountainous areas where these geological forces are strong. It looks similar to granite but has a more textured surface due to metamorphic origin. Both quartzite and granite are popular for construction and decoration because of their toughness and attractive appearance. Next, slate. Slate is a gray metamorphic rock with a smooth texture, formed from shale or clay-rich rocks that undergo intense pressure and lose water over time. It's hard, doesn't absorb water easily, and forms in regions where rocks are transformed by high pressure and heat. Slate is similar to other fine-grained metamorphic rocks like chlorite, muscovite, and biotite, which are found worldwide in areas with metamorphic process.
For minerals, there are three types of it, which is metallic, non-metallic, and precious. I will talk about metallic and non-metallic. For metallic, we found gold ore, which has dark gray to black color, and luster of metallic with hardness of 2.5 until 3. For non-metallic, we found calcite, which has white to light beige color, and luster of vitreous to pearly. It has hardness of 3 and specific gravity of 2.71.
Greetings everyone, my name is KNS1102 and today I am going to present for precious, which is diamond crystals. A diamond crystal is a native type element, which is typically clear or white, can be blue, yellow, brown, or even black due to its impurities. The texture is smooth and extremely hard, and its formation is formed under high pressure, high temperature conditions within the Earth's mantle. As for its properties, the luster of a diamond crystal is brilliant adamantine luster, and as for its hardness, it's 10 on the Mohs scale, the hardest known material on Earth. As for its cleavage, it is perfect in 4 directions, and as for its occurrence, it can be found in kimberlite and lamprorite pipes and also alluvial deposits. As for similar materials, it is similar to mesocyte and cubic zirconia. Next, we are going to talk about fossil identifications. There are 3 main fossils that we are going to talk about today, which are macrofossil, microfossil, and trace fossil. As for the first one, microfossils, for example in the image, fossiliferous limestone. Macrofossils are the large fossilized remains of plants and animals, typically visible without the use of a microscope. Fossiliferous limestone is a sedimentary rock that contains an abundant amount of microfossils such as shells, corals, and bones. These microfossils provide valuable insights into the ancient environments where they are formed, helping geologists understand the Earth's past diversity and ecological conditions. Moving on to microfossil, for example, index fossils. Microfossils are tiny fossilized remains of organisms, often smaller than 1 millimeter, that require a microscope to be observed. Index fossils are specific types of microfossils that are used by geologists to date rock layers. These fossils are particularly useful because they are widespread, abundant, and limited to a short span of geologic time, allowing the precise correlation and dating of sedimentary rocks across different regions. And lastly, we're going to talk about is trace fossils. Trace fossils, also known as ichnofossils, are preserved evidence of the activity of ancient organisms rather than their physical remains. Examples of trace fossils include footprints, burrows, feeding marks, and fecal matter. These fossils provide future crucial information about the behavior and interactions of prehistoric life, shedding light on how these organisms live, moved, and interact with the environment. That is all from me. Moving on to the next presenter.